Alrighty. Hey everyone. Welcome to Cassandra Lunch number 88. Today's topic is going to be on semi-structured data in Cassandra and how we can store and parse semi-structured data using Spark. And today's topic is going to be given by Stefan, who's an engineer here at Anant. Current co-organizers for this event are Rahul and myself. If you are interested in giving a talk at Cassandra Lunch or even our sister lunch, Data Engineers Lunch, feel free to drop a comment on the YouTube video and we can reach out to you. We are also looking for sponsors, so if you're interested in sponsoring Cassandra Lunch or Data Engineers Lunch, you can reach out to me, arpan.patel@anant.us. We are part of Data Community DC. Data Community DC believes in building an inclusive environment. So no matter your race, gender, sexual orientation, everyone is welcome, and we respect to be given to all. Data Community DC is built up of a bunch of different organizations. Our sister lunch, Data Engineers Lunch, is a part of Data Wranglers DC. If you're interested in all the various organizations that fall under the umbrella of Data Community DC, you can find out more at datacommunitydc.org and all the various events that are put on by the various organizations. So what do we cover here at Cassandra Lunch? We cover everything that is Cassandra, talks Cassandra, or plays nice with Cassandra. So whether that be open source Cassandra, enterprise Cassandra like DataStax, or compliant or variants like Skilla, Cosmos DB, Keyspaces, Amazon Keyspaces, Yugabyte. So anything that is Cassandra or talks Cassandra, but then also we cover things that play well with Cassandra. Like today, we'll be covering Spark and Cassandra. So Spark, Kafka, Airflow, etc. This is a point in time. If anyone's new on the Zoom or YouTube, don't forget to drop a hello in the live chat or comment below as well to introduce yourself. What do you do with Cassandra? What do you hope to get out of Cassandra Lunch? Again, if you are interested in, or if you're looking for certain topics to be discussed, we're taking suggestions as well, so feel free to drop them as well. Group rules: if you have a question, ask it. Be polite and courteous to others. This is a community, so please do share what you know with us. So the more you know, the more everyone will know. Here at Anant, we design, build, and manage global real-time and data analytics platforms surrounding Cassandra, Spark, and Kafka. So Cassandra and Spark and Kafka are our bread and butter. DataStax is a partner and a sponsor. GW University helps sponsor in-person venue space when we have in-person events. We have some organizational and institutional sponsors as well. Anyone have any announcements, jobs, meetups, hackathons? You can drop links and stuff in the YouTube chat as well as the Zoom chat. One announcement we have is DataStax Astra's Buildathon. It's already started, I think, last week, the first month. So the way it works is that there's 3 months and 3 rounds of challenges, 1 round of challenges per month. And there's prizes to be won for each monthly challenge, but as well, the top 3 winners qualify to present their project ideas at the demo day, which will be on May 28th. So if you weren't able to sign up in time for the first round of challenges that started this month, you can also do so for next month and the month after. So you can still qualify for the demo day if you end up being the top winner for that specific monthly challenge. But again, there's a ton of cash prizes as well as swag prices. Anant is hiring full-time or part-time positions related to data platform operators, engineers, and architects. If you are interested, you can find out more at careers.anant.us. Cassandra Lunch is now on Thursdays, currently at the same time at 12 p.m. Eastern. We are looking at having a more variable time slot so that way we can cater to a broader live audience in other parts of the world. But again, these events are live streamed directly to YouTube. So if you're not already subscribed to our YouTube channel, youtube.com/AnantCorp, make sure you do that. So that way, even if you miss the live event, you can always catch it on the YouTube channel right after or while it's live. Some upcoming Cassandra events: Cassandra Lunch, again, every Thursday. And then Data Engineers Lunches we have every Monday at noon Eastern. You can find out more on our events. Cassandra Lunch, all of these videos are available on the Cassandra Lunch playlist. So whether you search in YouTube or search on Google, if you search for Cassandra Lunch, you'll be able to find the whole playlist. We started recording around Cassandra Lunch 10. So from Cassandra Lunch 10 to all the way till today, Cassandra Lunch 88, you'll be able to find them in that playlist. Cassandra.Link should be your #1 resource for all things Cassandra, whether that be Cassandra itself, but then also Cassandra Spark, Cassandra Kafka, topics and resources and articles. Cassandra.Link is hand curated by the team here at Anant. So if you have any questions related to Cassandra or anything in the ecosystem, check out Cassandra.Link. It should be your #1 resource for all things Cassandra. And with that, we'll go ahead and pass it over to our guest speaker for today, Stefan.
Thank you, Arpan. All right, are you guys able to see my screen?
Yeah.
Thank you. All right, hello everybody, my name is Stefan. Today I will be presenting on semi-structured data in Cassandra. We're going to talk a little bit about different types of data, different types of representation of data in Spark, and then we're going to have a demo of loading that semi-structured data into Cassandra using Spark. So first of all, let's talk a little bit about Spark. So it's a unified analytics engine for large-scale data processing. It achieves high performance for both batch and streaming data using state-of-the-art DAG schedulers, query optimizer, and a physical execution engine. It offers over 80 high-level operations that make it easy to build parallel apps. And you can use it interactively from the Scala, Python, R, and SQL shells. Today we'll be taking a look at the Scala shell. And then powers a stack of libraries, including SQL, data frames, machine learning, GraphX, Spark streaming. You can combine these libraries seamlessly in the same application. And you can run Spark using the standalone cluster mode on EC2, Hadoop, Mesos, Kubernetes, and other stuff. Okay, with that out of the way, let's talk about a little bit about data, and more precisely the different types of data. Basically, the three major types of data that we can say exist is structured, semi-structured, and unstructured data. So structured data is generally tabular data represented by columns and rows in a database. Database is the whole tables in this form are called relational databases. In structured data, all row in a table has the same set of columns. So we use SQL to talk to, sorry, is there somebody on here?
Yeah, if you're not speaking, can you please mute yourself? Or Max, can you? Yeah, thank you.
Yes. Okay, yeah, I was saying SQL is a programming language for structured data. And some of my favorite SQL databases are Postgres, MySQL, but obviously there are a lot more. And then let's moving on semi-structured data, so semi-structured data is information that doesn't consist of structured data, but still has some structure to it. Some of this may include like something like JSON or an XML. And this is kind of data that usually is the most popular, the most, in web development, I guess it's something that is used a lot. And then at the end, we have unstructured data. And it is information that either does not organize in a predefined manner or not have predefined data model. Unstructured information is a set of text-heavy, but may contain data such as numbers, dates, and facts. And it can be like binary files, logs, audio, and video. So with that out of the way, let's talk a little bit about relational and non-relational data. So relational data would be considered something like PostgreSQL, MySQL, and relational databases provide undoubtedly the most well-understood model of holding data. The simplest structure of columns and tables make them very easy to use initially, but the inflexible structure can cause some problems. We can communicate with the relational databases, as mentioned before, with SQL, and SQL allows the joining of tables using a few lines of code. And then on the other hand, we have non-relational databases, non-relational data, which is where Cassandra falls into, and non-relational databases permit us to store data in a format that more closely meets the original structure. A non-relational database is a database that does not use tabular schema of columns and rows found in most traditional database systems. It uses a storage model that enhances for specific requirements of the type of data being stored. And in a non-relational database, the data may be stored as JSON documents, as simple key value pairs, or as graph consisting of edges and vertices. Some examples might be Redis, Genus Graph, Cassandra, MongoDB, Rabbit, MQ, and others. And then we're just going to quickly mention the type of data. So we have like documented data stores, we have columnar data stores, key value data stores, graph data stores, time series, and so on and so on. Next, we're going to talk about a little bit more deeply into about the differences between structured and unstructured data. And so the first part is structured data is undoubtedly a defined type of data in a structure, and structured data lives in columns and rows and can be mapped into predefined fields, while unstructured data does not have predefined data format. Again, structured data is generally quantitative data. It usually consists of hard numbers or things that can be counted. Methods for analysis include classification, regression, and clustering of data. Unstructured data is generally categorized as qualitative data and cannot be analyzed and processed using conventional tools and methods. Understanding qualitative data requirements advanced analytics techniques like data stacking and data mining. So we have storage in data lakes versus data warehouses. So structured data is generally stored in data warehouses, while unstructured data is stored in data lakes. Unstructured data requires more storage space, while structured data requires less storage space. And as we can kind of take a look here at this image, we have, which I thought was pretty interesting, was the estimated 20% of enterprise data is structured data, and then 80% is unstructured data. As we mentioned, it requires less storage, more storage. It's easier to manage and protect with legacy solution, while unstructured data is more difficult to manage and protect. And with that, we're going to talk a little bit about data representations in Spark. So resilient distributed data sets, or RDD in short, is a distributed collection of data elements spread across many machines in the cluster. RDDs are a set of Java or Scala objects representing data. A data frame is a distributed collection of data organized into named columns. It is conceptually equal to a table in a relational database. And today we'll be mostly we'll be taking a looking at data frames. So we'll be working with data frames. And dataset is also an extension of data frame API that provides the functionality of type-safe object-oriented programming interface of the RDD API and performance benefits of the Catalyst query optimizer and off-heap storage mechanism of a data frame API. Today we'll be taking a look at the demo. It's going to be consisting of starting Spark, loading a JSON file into a data frame, and then that data frame into Cassandra. We'll take a look at the same thing with an XML file, and then we're going to parse through an XML inside of Cassandra table and load the data into data frame, then that data frame into Cassandra. Okay, so with that out of the way, let's take a look. Okay, basically prerequisites for this, something that's done off screen, right, is I already have a Cassandra running on Docker. And if you would like to follow along with this, I'll share the repository here on the chat so everybody can take a look. And yeah, the only thing you need to do before this, if you want to follow along, is just start up a Cassandra server on Cassandra database on Docker. Firstly,
could you increase the zoom if possible?
Oh yeah, sorry. Should this be fine?
Yeah, that's good.
Okay, yeah. All right, let's take a look at how, let's start Spark, right? So to start Spark, we can just quickly type right? And all this is basically written down in the repository, but also whenever Spark launches, we can just take a look at the localhost 8080, and it will give us the Spark domain. Now we're going to use that. Start. We're going to copy this thing. So we're going to start the worker. And if we refresh, we'll see that we have one worker up and running. Next, we're going to start an application using the script here. And basically what it does here, what we're saying is we're going to take two packages, one from DataStax and one from Databricks for XML. We're going to point the master node, and we're going to say the configuration of the Cassandra connection, which is going to be 127.0.0.1 and 94 as the exposed port. So while this thing loads, and we can see that we already have a running application now to the shell. Now, the first thing we're going to do is, let's say we have a JSON file, and I don't know if you guys can see it on the left, but this is an example JSON file without the space, without the spaces. Really important, and we want this to transform it. We're going to put this into a data frame, read the schema of it. We can read the data in it, and then we want to create a Cassandra table based on the schema of the JSON file. And then we're going to insert the data into that Cassandra table. First thing we need to do is get some of the imports in, and path is going to be the path of the file, and then we're going to read using Spark read. And as you can see, we already have the fields mapped up. And if we want to take a look at the schema, how it looks like, we can just say print schema. We can also show some part of the data. And we can take a look at 4 samples of the data. And now let's say we want to get this data frame into Cassandra. We're going to start a Spark session, and we're going to create a new table based on the schema of the data frame. And we're going to say this, because I already have this table in, let's say people1. And let's quickly spin up Sage. And let's say as you guys can see, we have a new table created using Spark, which the primary key is going to be phone, the clustering columns are going to be the name, and all of the fields here are all the fields here. So Spark took care of the creation of the data. And now we want to say, write whatever data was in the JSON file into that Cassandra table. Actually, let's see, people, different table. And now the data that's in the JSON file is inside of our table in Cassandra. Obviously, there's more. And basically, the same thing can be applied for using an XML file as well. Let's see, I think if we have all the imports ready here. So again, we have Spark read using the XML package from Databricks. And again, we can say to you that print schema, and we can see the schema of that XML file, right? And we can say not show for, it's a big file, and you can see the ID, author, description, price, and all that stuff. We can actually even say, we can actually even filter, but we'll get to that, right? And we can do the same thing. We can create another table consisting of the same columns in the data frame, and then post that data into Cassandra. So just to save a little bit of time, let's take a look at that. Right, and we can see that we have all of the fields here into our table. But that's just basically reading data from a file. What if we have an XML file or a JSON file in one of our tables, right? And for this, just to make it clear what I mean by this is we have a table, we have a title ID, and we have a field called XML, which holds an XML fragment like here. So it's part of an XML file. And these are stored in our table. Now we want to get that data, and we want to transform it, parse through it, and then create a clean table out of that. And we can do that using Spark very easily. So first of all, we're going to read the Cassandra table. Let me see if I already have it. Okay. Yeah. And we can see here that show. And as you guys can see, the description column is actually the XML fragment. And we want to parse that, and we can really do that really easily with just 2 lines. And let's say well, actually, no, first let's parse this. So basically, we took the same data frame and we add a new field with indebted, filtered, parsed fields. And we can say, this is too small. We can say, take the price of those parsed fields and give me some of them that are above 8, or we can say above 2. We have more, right? So we can manipulate this data however we want, filter it, and then from here we can actually create a new table, and we're going to select. So basically, we're selecting which field we want. Let's say we don't want all the fields; we just want 3 fields, and we can say put it into this key space and this table, and with the primary key and the clustering columns that we decide. Title advice. Let me see if I. Or maybe we have this. Yeah, I think we already had that table. And I'm going to zoom out a little bit because this is too nice. So we can take a look clearly. Select all from all that. And as we can see, the columns that we decided are going to be in the data frame, the selected data frame, are going to be created now as a table. And we're just going to populate that data, the table with the data that we have in the XML. And I'm just going to say select all data, and we can see that now we have a table with a clean table with a clean set of information, and we can use that now for whatever we want. And yeah, basically that was kind of the whole demo that I wanted to show today. Kind of talk about different types of loading data into Cassandra using Spark, and different type of different type of data that's already loaded in Cassandra, taking it out and loading it back again. And at this point, if anybody else has any questions, feel free to share your thoughts.
Yeah, I have one question. So I know with Cassandra, you can use insert as JSON, I believe. But you can insert JSON formatted data. So is there a use case for using Spark and doing Spark reads of JSON as the load JSON, insert JSON, or is there, would it just be more simple, like excluding transformation processes? So say your process is only, I have JSON data and I need to put it into Cassandra, right? Is there like a use case for using Spark to do it, or would it just be just as simple just to do Cassandra insert with the JSON?
If you're just inserting a JSON file into Cassandra, then yeah, definitely using the JSON into Cassandra would be easier. I guess the only benefit you would like to first have it into Spark is if you want to use, like you said, some transformation, some kind of filtering, and just changing the type of data. Maybe you want certain type of data that goes into Cassandra, and the way you're going to create your table. Yeah, but basically, apart from that, if you're just doing the JSON file into Cassandra, it might be easier the way you mentioned it.
Gotcha. And then I guess another question I had was, I saw that you mentioned that you you imported the Databricks library. So is that XML aspect of doing Spark XML that's required by, or is that functionality not available in the like Cassandra Spark connector? Do you know?
With XML, I think not. I don't think that they have something like that that I'm aware of. This is the thing that I found, and it works great. But for as much as I'm aware, I think not. I think would be definitely I would have used that if kind of like DataStax had their own like XML parser or something like that, rather than using Databricks. But I think this is the one.
Gotcha. There's a couple comments from Rahul in the YouTube chat. I think relating back to the JSON question. With Spark, you can parallelize and transform while you are inserting. So yeah, coming to that aspect of doing transformations. And then also insert statements would have to be sent to different nodes via different calls to parallelize using core Cassandra distribution of traffic. Okay, gotcha.
Yeah, Spark is kind of like a large subject, and deeply not really got really into deep into it. Maybe it's my first baby steps going into Spark, but I'm definitely excited to learn more. Kind of see what are the different, like what I can do with RDDs. Maybe see how you can kind of transform unstructured data using Spark. I think you have talked a little bit about that in a previous Cassandra Lunch or Data Engineers Lunch, ARPAN, but yeah, definitely it's an interesting topic to explore. Okay, well, if there's, is there any more questions? Or, if anybody wants to add something.
Yeah, there's a comment from Rahul in the chat. "Quote unquote, Spark is a large subject." Yeah, it's a understatement of the year. Spark is huge. The ecosystem of Spark is massive. There's so many things you can do with Spark. Just even discounting machine learning in terms of just analytics of Spark, but then when you take into machine learning and like R and all the statistical analysis, because I actually have a friend that is doing his PhD in chemistry, and he uses Spark and R for his analytics. So it's kind of interesting to talk with him because like he'll sometimes send me some Spark questions if he has something, but sometimes I can't help him because he's some of the things he's working on I haven't really worked too much with, but sometimes I can send him in the right direction.
Yeah, kind of like with Spark, you think you can use Spark for data engineering and data science, right? Like you can use Spark for different types. Just knowing the different types of things that you can do with data, and then how much Spark comes into play with it. I don't know if maybe there's something similar to Spark that can do as nearly as much as it, but I think it's like the ultimate tool for data.
Yeah. Let's see. Are there any questions or additional questions from the YouTube chat? Feel free to drop them in the live chat, or again, if you have any comments, you can drop them in the comment section as well. But any comment or questions or comments from the Zoom chat as well, feel free to speak up or drop them in the chat. Okay, looks like there's no other questions. Before we hop off here, sorry, I'm just trying to lost my Zoom real quick. Stephanie, if you don't mind letting me take back over. Yep, thank you. So again, just to shout out, Cassandra.Link should be your number one resource for all things Cassandra. You can look through all the various tags we have here and as they relate to stuff. So when you see a tag like Kubernetes, it's going to be related to Cassandra and Kubernetes. Again, these are hand curated. Also, don't forget to check out Cassandra.tools. Bunch of different tools on here, open source. Some have enterprise options or managed options, but if you're looking for Cassandra related tools for anything you're doing, you can go ahead and check out Cassandra.tools. You can filter, you can also search for certain tools on here as well. If you do have any suggestions for Cassandra.tools, feel free to drop them in the YouTube comments or reach out to me, arpan.patel@anant.us, if you want to see something be added to Cassandra.tools. We want this to be available to the community. So if you have any cool tools related to Cassandra that you want others to know about, feel free to reach out to us. And with that, we will go ahead and wrap up today's Cassandra Lunch. Thank you, Stefan, for giving your talk. And as mentioned, don't forget to like and subscribe if you're watching on YouTube. All of these events are live streamed directly to YouTube. And if you have any topic suggestions or topics that you would like to give a talk on, either for Cassandra Lunch or Data Engineers Lunch, feel free to drop them in the chat as well as the YouTube comment section. And we will see you guys next week.